Hi, I'm Caroline from Doodles and Digits, and did you know that there's math all around you? Today, we get to go behind the scenes of 3 different places that use math every single day. We're going to first start out by interviewing a structural engineer, where she tells us how she uses math to build large buildings. Then, we're going to go to a physical therapist, where she explains how she uses angles to measure different joints. Finally, we get to go behind the scenes of a ski resort where they show us how they use math to make snow. Get ready to see the math in the real world.
Doodly doodle, doodly doodle, doodly doodles and digits. Area, symmetry, fractions too. It's all here for you.
Have you ever been curious about who designs the structures of a building? Today we're going to talk to a structural engineer and see how she uses math. Let's get into it.
My name is Faye Garstang and I am a professional engineer. I work for Schaefer and we design structures. So as structural engineers, we creatively choose and design the material, the pieces and parts, to make the building possible.
All right, so what exactly is a structure?
So you can think of a structure as anything that is built. From a tree house to the Golden Gate Bridge, it all started with somebody's idea, and somehow all of it had to come together. So structural engineers, we take that vision that our client has or that we have, and we put the bones inside it and the muscles inside it. Everything that it takes to hold the building up, to make it safe, to make it serve its purpose. We have to design around the rest of the guts of the building, the HVAC, the air conditioning and heat, the electrical, the plumbing. We have to make it all fit. The first way that you use math as a structural engineer is that the building all has to come together, and everybody is contributing to that. So you have to be very precise in the way that you draw and detail the building. You have to make sure that you leave enough room for everything that needs to happen in between the bones and muscles. You have to make sure that the loads that you are putting on the building that you're designing for, they are correct, that they go to the right place, that all of the connections that we design for, I guess what you would call the ligaments of the structure, connecting everything together, that they are strong enough to hold the building up and that they are in exactly the right place. You also have to make it easy to build, so you have to have an understanding of what people can do with the materials, with the wood or the steel or the concrete. All of that has to come together in the building, and each piece is dimensioned. It has a length, a width, it has a weight, and so we use numbers all the time for that, and they just become all the little pieces that fit into this puzzle. And we use geometry all the time, just to lay out the building. We work with the architect's plans, the way that they would like to see the building and the way they'd like the building to work, and then we have to fit everything in. So geometry is a big thing, but we don't only use geometry for laying out the physical pieces of the building. We also use it to imagine or envision the loads on the building. For example, if you're designing a structure or a building for a heavy snow load, the snow falls down on the building and it comes like a blanket on the roof. But then the wind blows and it pushes all of the snow to one side, up against a wall. Now, that snowdrift, that forms a triangle. And when we are designing the beams, the joists that support that roof, we have to design it for more snow on this side than we design it for on the other side. We do that by figuring out what the height of the triangle is and the length of the triangle, and then deciding how much of that weight goes to each part of the building underneath it. So that's one way that we use geometry to imagine what the structure needs to carry on the roof.
Quick questions with the structural engineer. What is your favorite thing about math?
The interesting thing is that I didn't know that I liked math when I was a kid. It's only when I started wanting to solve problems that I found out that I liked it. I thought about math like a hammer. I was not interested in hammering things, but when it came time to build things, it became very interesting to me. It's a tool that you use to get what you want done, and if you're a creative person, this tool works its way into your life all the time, regardless of what you're doing.